Hi, Precalc. This is ellipses day 1. So we're going to be doing ellipses for a couple days here, and then after we're done with ellipses, we have one more conic section to talk about. We've already covered circles and parabolas up until this point. So similar to how we started off with parabolas, let's say, when we only talked about a vertex at 0, 0, today we're going to start by talking about ellipses that are centered at the origin. And then as we move throughout the week, we'll move the center to somewhere else in the coordinate plane. But just to kind of understand some of the basic properties that ellipses have, first and foremost, if the center is at the origin, we're going to come up with one of these two possible equations. So a little bit different looking than what we've seen with circles and what we've seen with parabolas so far. But we'll get used to these just like we do with anything else in class. So it's going to be x squared over a squared plus y squared over b squared equals 1. So in standard form, you'll find that the ellipse is equal to 1. Or you might see x squared over b squared plus y squared over a squared equal to 1. So the only difference there is that you'll notice that the values of a and b are kind of interchangeable, and that may not seem like a big deal, but I'll show you what each of those would look like and how we can identify, what form a given equation is in. So if we're thinking about an ellipse, I hope that you're thinking about some sort of oval type shape. But of course, in an upper level math course, we probably wouldn't just say, hey, there's an oval. Here's two potential forms for what an ellipse could look like. So it might be stretched out from left to right, which is what would correspond with the red equation here. The purple equation might look something more like this, where it's stretched out up and down. So it's basically the difference in the orientation of the ellipse. I would call this a horizontal ellipse, and then this one over here a vertical ellipse. So those are things that we're going to become accustomed to talking about in this unit, whether it's horizontal versus vertically stretched. And the main way that we're going to know which way it's stretched out is that a is always the largest value. So when the a is underneath the x's, the larger number under the x's, it's stretched further along the x-axis horizontally. But meanwhile, if a is under the y's, it's stretched further along the vertical axis where the y values are. So I hope that that connection makes sense, but we're going to be able to tell if it's horizontal or vertical because a is always going to be the biggest value in our equation. So that will be a pretty important fact. What we're going to do is talk about some of the important points that are required in order to graph an ellipse, because that will be a big focus in this unit. And it does have quite a bit more than what we've seen with circles and parabolas. So I'll give you a second to sort of catch up to where I am in the notes. Hit pause if you need to. Sorry, that's certainly not my best ellipse. It's looking a little football-ish. But you guys just do your best to sketch an ellipse there. I kind of went, if you have graph paper, I went 5 out just arbitrarily in each direction to the left and right. And then I went up and down 3 from the center. That really is unimportant at this stage in the game, but I want to see if you can, let's just start with a horizontal ellipse being stretched out left to right that way. And as soon as you have that sketched, I'm going to start labeling some things in the diagram here. And at these endpoints on the left and on the right side, I'm going to call one V and the other V prime. It does not matter which one is which. I could put V on the left and V prime on the right, totally fine. But what I'll tell you is that from the center of the ellipse, which today is at the origin, to these points at V and V prime, which are called the vertices, that's going to be the distance defined by A. Okay, so A is the distance from the center to the vertex points. So once I know the value of A in the equation, I'm going to start at the center and then either go left, right that direction or up, down, depending on which way it is, horizontal or vertical. And the segment that connects V and V prime, V to V prime, it has a length of 2A, and it's known as the major axis. It's the larger of the two axes that kind of connect and form the ellipse here. So that's going to be an important word to sort of keep track of. All right, at the top and bottom, these points, I'm going to call those B and B prime. And these endpoints, to get there, well, it won't be too surprising that we're going to use the value of b in the equation. So little b is the distance from center to, now it doesn't have a special name, I'm just going to call it the end of the minor axis. So not too surprising there that if we have a major axis going this way, the minor axis is going vertically. And the connection from B to B prime has a length of 2b, which in total is known as the minor axis. Now, you may recall at some point learning about ellipses, probably when you're in earth science way back when, learning about planetary motion and things like that, since we travel around the sun in an elliptical path. And you may even do a lab in earth science that requires you to like poke 2 holes in your paper that create what are called foci or focal points. And then you kind of loop a string around, and if you connect it, you'll form the path of an ellipse here, okay? So every ellipse has 2 what we call foci. So I'm gonna put those, I'll put it right here and right here. Those are equally spaced about the center. I'll call one of them F and the other F prime. So the way we get to the foci from the center is we're going to use a distance called little c. So c is the distance from the center of the ellipse to the focus, plural of that being foci. So where is this value c going to come into play? Well, I'll tell you that this distance that I defined here as being a, from center to vertex. If we were to copy that same distance, it would actually match up perfectly as the distance from the focus to the end of the minor axis. So this distance is also a length of a. If you don't want to include that in your picture to make it look less busy, I completely understand. But that distance is also a length of a. So because of that, if we, let's say, just denote this length down here as c, how colorful is this getting? This is really nice here. If I call this length c, now we have a little right triangle that we can use the Pythagorean theorem on. So a very important relationship in an ellipse is that a squared, because a is the hypotenuse here, equals b squared plus c squared. So the way that we're going to get to those foci, the value of c, is we know the values of a and b from the equation. We're going to use that a squared would be equal to b squared plus c squared. A little bit tough because I know we're used to seeing c squared on the other side when we're doing Pythagorean theorem, but it is important that we keep it in this order so we don't make any errors. Last thing I want to talk about for now is that there are segments that connect through the foci, and these have the same type of name as what we had for the segment that went through the focus in a parabola. So notice I just drew in these vertical segments that went through the focus. They're perpendicular to the major axis here. Okay, if you label these endpoints as kind of like E and E prime, this might start to look a little bit familiar. So the connection from E to E prime, that is the length of the latus rectum. And these actually, since we have 2 segments, they are latus recti. Very fancy here, okay? So we are going to have a length of the latus rectum in an ellipse, which you guys know we just call the LR. And without going through the derivation right now, although if you're really interested in it, which I know you might be, email me, I'll send you the derivation. The formula for finding that length is 2b squared over a. So luckily we'll know that information. We'll know the value of b, we'll know the value of a from the ellipse equation. But what that means is that that's the total length of each of those segments. So this has a length of 2b squared over a, and this one also has a length of 2b squared over a. So what we're going to see is to get to the endpoints of the LR, this distance here is up b squared over a. This distance here is down b squared over a. So the total length there is going to be 2b squared over a. And I know this picture has now gotten really busy looking, so hopefully you've made some sense of it in your notes, but I think what we're ready to do is probably, let's just get right into making a complete sketch of an ellipse. So if we take a look at the equation, let's see if I can slide this down here. X squared over 64 plus y squared over 25 equals 1. Okay, just for consistency purposes, I'm going to write the center down today, even though we should probably know the center is always going to be the origin for now. The center in this one is 0, 0. The next thing is I like to identify are the values of a and b. So remember, the numbers underneath here are representative of a squared and b squared. And remember that the larger number is the one that I'm looking at for a squared. So this right here is my a squared currently, and then this is my b squared. So based on that, I now know that a is 8 and b is 5. And since the bigger numbers underneath the x's, a squared, the major axis for this one is going to be going left and right. So this is going to be one of those ellipses that's more stretched out horizontally than it is vertically. Okay. So based on that, we can probably start sketching already the ellipse. But I'm going to do one more thing. I'm going to find the value of c, because that's going to get me to the foci. So c comes from this equation. A squared equals b squared plus c squared. So 64 would equal 25 plus c squared. We subtract the 25 over, c squared equals 39. Square root, square root. Okay, I'm going to leave c as radical 39 when I go to write coordinates later. But radical 39, if we need an approximation for plotting it on the grid, that's just going to be a little bit bigger than 6, isn't it? Right? Because the square root of 36 would be 6. So if I need to know how far left and right to go to get to the foci, I'll go a little bit more than 6. Okay, I think if I'm ready to go here, I'll try and be good with the scaling. Let's see if we can fit it in. Okay, so start with a point right at the center there. Sorry about the coughing in the background, guys. All right, so I'm going to go left and right 8 units, and that's going to get me to the points that are called the vertex points. That's what the value of a does. So if I go 2, 4, 6, just kind of squeeze that in there on the left, 2, 4, 6, 8. Looks like I'm going to fit both of those. Okay, it doesn't really matter where you put the v, where you put the v prime, but those are the vertices. The value of b is how far in this case up and down we're going to go. So up 5 and down 5. Okay. And from there, you actually can just connect those. It's going to be maybe a little bit of a better ellipse than when I start with it. Oh, that's very nice. Okay. That's essentially what the ellipse looks like. Now, there are some other things that I would like you to include in your ellipse just to make the sketch look a little bit nicer. So we're going to include where those focal points are, f and f prime. So the radical 39 value, the value of 6, you're going to go out a little bit more than 6 to the right and a little bit more than 6 to the left. And you can label those as the f prime and f points. I usually leave the primes together and the non-primes together. It doesn't really matter though, guys. Okay. All right, let's start listing some of these coordinates, and then we'll go back in and talk about the LR and things like that. So the vertices for this one, v and v prime, they went left and right 0, right? So they're at 8, 0 and negative 8, 0. Here's where I'm going to get fancy on you, just like we saw with parabolas a little bit. I'm just going to list that as plus or minus 8, 0. I'm going to list them all at once. This way I don't have to worry about, writing them all separately, because it's pretty easy in these cases to list them together. B and B prime are the ends of the minor axis going up and down. So the x coordinate is 0, the y coordinate is the plus or minus 5. The foci went left and right, so f and f prime are at plus or minus radical 39. So notice how I'm not using that 6 decimal, whatever that number would have been. Okay, I only use that to get to those where those were plotted. Okay. Moving on to the length of the LR. We haven't really looked at this in the diagram yet, but in general, it's 2b squared over a. So b squared in this case was 25. And then a was 8. Okay, so we're going to get that the LR has a length of 50/8. If you want to reduce that, you can. It would be 25/4. So 25/4 is the length of this segment and the length of this segment over here. And if we were accurate about our sketch, 25/4 is going to be let's see, a little bit bigger than 6, right? 6 1/4. So this total length, if I went up 1, 2, 3-ish, and then down 3-ish, yeah, it should be that this length is about 6 1/4 on each side. Okay, if it's not in your picture, not a huge deal. I'm not exactly grading you on that part of the accuracy, but that's the length of each of these segments. So then the last thing is, then what are those endpoints coordinates going to say? So the coordinates E and E prime, last step. Notice how those coordinates are in line vertically with the foci, okay? So to get to the endpoints, you have to go, first of all, left and right, that radical 39 value. So it's going to be plus or minus radical 39. And then the last thing you have to do here is say, all right, well, if this whole thing is a length of 25/4, I have to take this and I have to cut it in half to get how far up and down to go, right? If this thing has a length of 25/4, half of that would be 25/8. So if you go up 25/8 and down 25/8, I know that's kind of a weird number, then the total length here would be 25/4. Okay, and you can check it out. Because if you do 25/8 plus 25/8, that's 50/8, which was the entire length of the LR. But that's how far up and down we should go from the focus coordinate of plus or minus radical 39. This is the part that will take the longest to get used to, but we're going to do enough of these that by the end, you should feel pretty confident with it. Okay. All right, let's just do maybe 2 others for practice quick, and then you guys can try out some of the ones on the homework. All right, next one is 16x squared plus 9y squared equals 144. And as I started writing this down, you might have been saying, like, wait, I didn't bargain for this, Mr. All. Where are the 16 and the 9 coming from? I thought there were supposed to be fractions involved here. And you're absolutely right, there should be, because what I mentioned at the beginning of the lesson is that in standard form, the ellipse has to be set equal to 1. So the only thing you're going to do to get started is, and this will be a common practice eventually, is just divide both sides by 144. Okay, make this into a 1 on this side. And then over here, luckily 16 and 9 go into 144 nicely. Okay, they should when you're dealing with these equations. Otherwise, you probably made a mistake. Okay, but in fact, 16 times 9 is 144. So this becomes x squared over 9 and y squared over 16. Okay, now that I have that info, the center of the ellipse is 0, 0 again. We need the values of a and b. Be very careful with a and b. Remember, a is the larger of the values. So a is going to be 4, so that's my a squared. B is going to be 3. And since the larger number is underneath the y's, the major axis in this one is going to go vertically. So you're going to see an ellipse in the end that's graphed, and this is a super rough sketch, but it's going to look something like this, a major axis that's vertical. I like to find the value of little c, so I can get to the foci. A squared equals b squared plus c squared. So 16 is going to equal 9 plus c squared. So if you solve this, you're going to get c equals the square root of 7. Square root of 7 is less than 3. It's 2 point something, right? So if we need that for graphing purposes, we can use that. All right, I think that's good for now as far as what we'll need for the sketch. So let's go ahead and draw a set of axes here. Okay, just remember that if the major axis is vertical, that distance A, which is 4, is going to tell you how far up and down to go. So if I go up 4 and down 4, those are the vertices, V and V prime. Okay, if I go left 3 and right 3, these are the ends of the minor axis, B and B prime. Once you've got those in there, go ahead and connect them, make your ellipse. Okay. From there, I'm also going to use that value of just a little bit bigger than 2. I'm going to go up that distance. Here's F. Down that distance. Just make sure the foci are always in line with the vertices. They are always going to be on top of the major axis somewhere. Okay, so make sure that foci, they're never going to, like, they wouldn't have gone outside the ellipse ever. They're always going to be on top of the major axis. Okay, so then the last thing we have to do is, now that we have that sketch, and we'll eventually talk about the LR, which in this case, they're horizontal segments. Okay, let's start listing some coordinates. The vertices went up and down. So V and V prime are at 0 plus or minus 4. B and B prime went left and right 3 plus or minus 3, 0. The foci went up and down radical 7. Okay, I'm going through that sort of quick there. Okay, the LR is 2b squared over a. So b squared is 9, a is 4. So it looks like that's going to, that's going to be 18 fourths, which would reduce to 9 halves here. Remember, that's the total length there. So the last part that takes a little while to get used to for E and E prime is, first of all, what do they share in common with the foci? They're in line horizontally with the foci, so they're going to share the same y value. So they both have y values of plus or minus the square root of 7. How do I get to the x values? Well, if this total length is 9 halves, I have to go to the right half of 9 halves and to the left half of that. So it's plus or minus 9 fourths there. Essentially what you can do is you can take the 2 out of the equation here and just do b squared over a. That's how far left and right you're going to go in this case to get to the ends of the LR. Okay? So if you have any questions about that, email them quick to me. I'll see if I can answer them. Otherwise, you'll see the same type of stuff come up in the future lessons this week. Okay.